Charles' law. Charles' law states that at a constant pressure, the volume of a given mass of gas is directly proportional to its temperature. The volume is directly proportional to its temperature. So as volume increases, temperature increases. When temperature increases, volume increases. This can be written as volume proportional to temperature, or V over T equals K, where K is a constant. So you can put it into this formula. V1 over T1 equals V2 over T2. When we look at a temperature versus volume graph, you will get a straight line. As you increase your volume, you increase your temperature, and vice versa. As you increase temperature, you increase your volume. Question. A partially filled party balloon contains 2.6 litres of helium gas at atmospheric pressure and a temperature of 12 degrees Celsius. What volume will the balloon occupy if it warms to a temperature of 20 degrees at atmospheric pressure? Okay, so pressure is remaining constant, and it's important to check that if we want to use Charles's law. So let's read like a story again. 2.6 litres of helium gas, that's V1 at a temperature of 12 degrees. Remember, we need to work in Kelvin. It's always Kelvin, Kelvin, Kelvin when it comes to gas laws. Okay, so we've got V1 and T1. When the volume of the balloon will occupy, it warms to a temperature of 20 degrees. So we've now got T2, and we're looking for V2. T2 again, Kelvin, Kelvin, Kelvin. We add 273, and we get 293 Kelvin. So V1 on T1 equals V2 on T2. Because these are ratios, we can write this as T1 on V1 equals T2 on V2, or we can write it this way around. As long as the T's are on the top or the bottom, so they're on the same side, and the V's are on the same side. Manipulate this formula around, and we get V1 on T1 times T2. Plug in your figures, and you get an answer of 2.7 litres. So have a go at question 13. A 5 litre sample of a gas at 50 degrees Celsius is heated until it occupies double its original volume at the same pressure. What is its final temperature? Give your answer in degrees Celsius. Have a go at this question now, pause the video, and I'll run through the work solution. Okay, so the answer is 373 degrees Celsius. If you got that right, you don't need to watch any more of this video. If you didn't, I'll run through the work solution for you now. So a 5 litre sample of gas at 50 degrees Celsius. So volume 1 has to be 5 litres, and temperature 1 is 50 Celsius plus 273 to get to 323 Kelvin. Remember, Kelvin, Kelvin, Kelvin. It's always temperature in Kelvin. Volume 2, it's double its original volume. So 2 times 5 is 10 litres. And we're trying to find out T2, which we'll work it out in Kelvin, but remember we've got to change it to degrees Celsius. So T1 on V1 equals T2 on V2. And as I said, you can put these, whether it's temperature on top or volume on top, it doesn't matter as long as it's both volumes and both temperatures. Manipulate that around and plug in your values, and you get an answer of 646 Kelvin. Remember, you've got to change it to degrees Celsius. So we need to subtract 273, so you get an answer of 373 degrees Celsius.